Hello my dear Sujwal, today I have a question which is a cantilever beam. Okay, as you can see, this is a cantilever beam, and this is the case of UDL. That means UDL. What does what is the meaning of this? This is uniformly varying load. This is one of the most important topic in case of if you are studying in university examination. UDL is most important, but whenever we are trying to draw shear force and bending moment for UDL, uniformly varying load, we really face little bit difficulty. So in this tutorial I'm going to make you understand each and every step. That's why you can draw UDL in case of cantilever beam. Okay, so this is, we are going to draw here shear force diagram, and in the below we are going to draw bending moment diagram. Let me extend a little bit this line. Okay, now first if you are going to get, if you're going to get diagram like this in case of cantilever beam, what we have to do, we have to first separate this little bit, and we have to name this as A, B, C, D and E. This point is now what I'm going to tell you, we are having two triangle A B C and triangle D E C. All right, so what we can do from this, we can take similarity triangle. All right, so what is the meaning of this? I hope you know about this similarity triangle. So according to this, we can write an equation that is AB upon BC is equal to DE upon EC. All right, so what is our main motto? Main motto is to find out DE from this equation. So what we can write here, DE is equal to AB upon BC into EC. Suppose EC is X. So what is the value of AB? AB is 10. BC is 4 into EC is X. So 5X upon 2, the value for DE here. Okay, so this is it. We have find out the value for DE. Now what we have to find out, that is most important, shear force for this triangle. I mean, if I will if I will say shear force for this section only, so what would be the value for this shear force at this section would be, that is, suppose that F shear force is equal to triangular load of BDE. So triangular load of not BD, it's DEC. So half base is EC and height is DE. Again we know that EC means X, DE means 5X by 2. So 5X square upon 4 shear force. Now think about this. What we can do from here, we can easily find out shear force, total shear force. So what we have to put in the place of X to find out the shear force for this, because of this triangle. So what we have to do, that is SF is equal to 5, X is 4, because we are going to find out total shear force from C to B. So 5X is 4 square by 4, that means 5 into 4 by 4, 4 cancel, that is 20 kilonewton. We are going to get shear force of 20 kilonewton. Okay, this is one of the way I have shared with you. I can tell you the simple way. If you are preparing for competitive examination, then I can tell you another easy method to find out total shear force here. Doesn't matter what type of question you are going to get, you have to just calculate the triangular value of triangular total triangle area of the triangle to get the total shear force acting on this beam. Okay, so how we can find out? You know the formula for finding out area of the triangle, that is half, base is 4, height is 10, so 5 is equal to 20 kilonewton. And here we also got 20 kilonewton. So this is the shortcut method, this is the long method I have shared with you. Okay, now most important topic, most important concept again I am going to share with you. If the fixed side is having maximum value in case of UVL, then okay, before going to tell you one that thing, I have to tell you another thing, that is what? In case of UDL, we have to draw shear force diagram in parabolic and bending moment diagram in cubic parabolic. Okay, that is one thing. Next thing, if this side, I mean this thicker side, this higher side is on the fixed side, so what we have to do, we have to draw parabolic diagram in case of shear force diagram that is fixed. But what, how we can draw the diagram? Okay, that is like this, like this. So what is the value for this? What is the value for this? 20 kilonewton. This is the diagram for shear force diagram in case of this cantilever in UDL case. Okay, now one thing is clear, we have drawn shear force diagram. Now how we can find out, how we can draw or find out bending moment diagram? That is also most important. So what we have to do, we have to draw this one, bending moment diagram. So bending moment diagram in case of this, I mean if thicker side is on the fixed side, so what we have to do, we have to just multiply this shear force standard formula 5x square upon 4 into x by 3. This is fixed, we have to do always if thicker side is fixed, either fixed or we will consider in case of simply supported beam. You understand that? Okay, I mean if you are considering to draw shear force and bending moment diagram, then in case of simply supported beam, then we have to fix one side to find out reactions and all those things. I hope you understand if you have solved few questions of simply supported beam. Okay, now what we can get from here, 5x square upon 4 into x upon 3. So what will be value? 5x cube upon 12. So again x is what, if I will put the value of 4, because I have to get shear bending moment of the whole. So what we have to do, I have to put the value of x as 4. So what is it? 5 into 4 cube by 12. So 5 into 16 into 4 by 12. So 4 3s are, that means 16 into 5 by 3. So what we have to do, I have to use calculator. Okay, let me show you the calculation. Yes, I hope you can see right now. This is 16, this is 5 by 3. Okay, sorry for that, I have to just make you understand this. Okay, 16 into 5 upon 3. Okay, so okay, now I have to calculate this. Okay, 16 into 5, 60 divided by 26. This is 26.6666 kilonewton meter. Okay, this is the total bending moment. Okay, 26.66. Okay, so now how we need, this is parabolic. Now again I'm telling you, this type of diagram we will draw in case of this condition only. If this diagram would be like this, I mean opposite, and this will be fixed, then this diagram will be like this. Okay, I'll share with you another question in this topic only. That's why you can understand that properly. Okay, so watch that video to understand that concept properly. I hope you understand it. Okay, now how we can draw, we have to draw is like this. This is a cubic parabolic we have to draw, and this is 26.6666 kilonewton meter, and this must be cubic parabolic. Most important thing I'm going to tell you, that is what, in case of UVL we have to draw shear force diagram parabolic Again, in case of UVL, we have to draw BMD diagram in cubic parabolic. One another concept is there to find out the value for bending moment diagram. But for that concept you need to use little bit tips and tricks. That's why you will be aware of solving that question. Okay, what is that? I am telling you, my dear, don't worry. We have to find out the area of this parabola. So in case of this type of diagram, we have to calculate, we have to use a formula for finding out the area of this parabolic diagram. What is that? 1 by 3 into base into height. So what is that? 20 into 4, 80 divided by 3. What is that? 26.6666. Exactly, we are getting here. So what I have shared with you today, two important concepts, two shortcuts to solve UVL. One of the most difficult question students told me. This is really important for you. I hope you understand the question. Well, thanks for watching. Hope to see you again in my next video. Bye bye.